All right, we are back with another learning C++. All right, playing with vectors again. Where was I? It's been too long. Wait, I already got one opened up. Right here. Right there. All right, what was we, main 3? If I go too long, I start forgetting everything. What is it? CL, not main. Let's see. Go through all these. Main 3, that was it. Right there. And then air handling, SC. I don't need debug. So let's do that. And then this was a vector example. Well, shoot. I did the wrong one. I was supposed to do 3. Main 3. Okay, there we go. So what was it here? Okay, so we were inserting at different places in the vector. Oh. So let's see, 5 and 19, we added the numbers, we pushed it back. Oh, that was it, yeah. So it defaults place at 0. I was going to put it in the front instead of putting it in the back. So it printed the number, the first one, whatever was at 0. Whoops. Which was 99. Five and 99. So 5 got pushed back. Place at 0 is 99. So it puts in 5. Place at 0 equals 0. Now I'm confused about my own code. Add num 599. I don't know what my logic was here. I should have put comments. So add num, I pass in 5 and 99, so place at 0 is 99. I insert 5, so numbers now has 5 in it. Place at 0 is true. Oh, that's what I did, okay. And then it inserted right here. I think that should be commented out more, because that was kind of confusing. Honestly, I think the default value kind of makes it harder to read. I mean, if you're thinking about it, it makes sense, but if you're just cold and you look at it, you're thinking, oh, it's 0. Where's the 99? Yeah. This should be something like, there you go, second number. That would be better. Instead of the operation that it was represents. Yeah. So that's that. So add num and second number, push back num. So this puts it if second number is true. There we go. Which true is defined as non-zero, even if it's negative. So yeah. So then we put this 99 in there. And we just, now remember it inserts it. So it just pushes the 5 onto number 1. That's what we learned in that one. Because I was thinking it would overwrite it, and it didn't. That's what we're doing here. Where's it at? See, it prints 0. And the number at 0 is 99 because we inserted that. And then it prints all the numbers, and see how it just pushed back to 5? That was surprising to me. I remember that. So Okay, now that I'm refreshed, what else is there? I'm looking at my C++11 book on vectors. It is Professional C++ by Rocks, second edition. One thing it says in here is size T. Can't remember what size T is. Let's see what it is here. Oh, God. All right, it's okay, Sparky. Somebody's fishing. Getting too close. All right, I gotta move locations. So, I'm at a pond. Because they gotta work their way around the pond. Once they get too close, Sparky starts going crazy. And he's still on the other side of the pond. If Sparky can see somebody, he starts barking. So he's a good guard dog. So we are driving to the other side of the pond near the entrance so I can just park off in the grass. Let everybody go fish. I was just on the road that's around the pond. Yeah, I haven't been able to program a lot. I've been stressing out over finding a job. I found a job up in Kansas, but since I live in my truck, I don't have anywhere to put my dogs. And so people complain that they're barking in parking lots and stuff, and I end up getting fired from the job. So it's kind of this brutal cycle that I can't get out of I can't find a place to live because I can't keep the job. I don't have anyone to watch them because that lasts about maybe a week at most, and as soon as they dig holes or dig under the fence, nobody wants them anymore. So, but I think I might have something lined up next week. And I've been working for a little bit of cash with a guy I used to work with. He cleans some buildings at night. So that came in handy because I was down to like $30. Man. All right, I got to put this little sun blocker up. Oh, let me see, Sparky. Watch it, turkey. All right, and then we can get back down to business. All right, let's put this up. All right. Open the door for air. Yay. Okay, can we please do this now? Okay, so I also got Bjorn Strawstrup's C++ programming language second edition, which is really old. I wonder what it has in here on vectors. I mean, if the STL was even around back then, I don't know the history of all that. Let's see. Might just go online. TV. Variable, blah, blah. Yeah, there's vectors here. Let's see. Bit vector. You ever heard of a bit vector? Page 94. Oh, it's defining. Oh, that's something totally different. So 32 and 30. Oh, Sparky. All right, go. You guys lay down. Lay down, he's gone. Yeah, so in this book, you had to init the vector before the first use of a vector. So they must have changed all that later on. So I don't remember seeing any of that. I'm going to do that later. Yeah, because this had like a vector destructor. So the new keyword is automatically garbage collected. C++ does not require the implementation to reclaim storage allocated by new when it becomes unreferenced, blah, blah. Yeah. Yeah, that book is way too old, especially for vectors. Let's see. But a vector is a sequential container. I learned that one. All right, what else is there? Let me see. Iterators. There's a lot to this. Let me see. Fixed length, dynamic length, the blah, blah, blahs grow dynamically. So that was, the ability to grow dynamically was demonstrated here. Because see, we created it with 1, but then we added 2 numbers. So it does do that. I wonder what the algorithm is for that, if it just doubles or what. Because I think, if I remember in C#, like the string builder, it would start at like 16, and then after that, start doubling. But I don't know if it doubled, you know, if you put like, because I never used that. I'd always try to use like 100 or something. Something where I knew it would be close to my use. Because you want to do that. If you know that you're going to have like 200 entries, eventually go ahead and do that. Just create it at 200. Don't let it grow to 200. That's in anything, really. Any kind of dynamic array. Because usually you're going to have a lot more than the initial length of it. Oh, one thing I wanted to see. Where's my phone? Let me hook into the internet real quick. Just want to see this size T. I vaguely remember it. Let me see. My phone might get cut off next week. I need money. I need to see if AT&T will let me push it out a week or two. All right, we are logged on the AT&T 5G network. Actually, I think it was 5G plus. All right, let me see. Should we go straight for Copilot? See what it says. Come on. I don't have a whole lot of disk space anymore, so I think everything takes longer to fire up. Let me see. Okay. Let's see. C++. What is size T? Unsigned integer type. Any object in memory, which is why it's okay. Okay, so guaranteed to hold the size of any object. Okay, so when in doubt, use size T. Unsigned integer type to find errors such as okay. So it's platform dependent. 32 or 64, yeah, I mean, it's unsigned int. The reason is portability then, whether you're going to run it on 32 or 64-bit. For most of your applications, as long as you're not going over the limits on 32-bit, it wouldn't matter whether you're doing size T or unsigned int. But if you were working on a 32 and then you went over what the 4 billion or whatever it is, the max, into 64-bit land, then that would overflow it. Okay. Yay. Now we know. Okay, let's do that. Oh, let's fire this up one more time. Let me go ahead and get C++, vector methods. This one here. See, that's the thing. This is unchecked. So if I do this, it doesn't check it. You'd have to use at. Now that was interesting because you could do. So at this point we have 2. So if we did down here and go numbers 8 equals 55. Actually, let's pull it up in here. There, blah, blah, blah. Let's do it right here. And that should be undefined behavior. There's only 2. Because I don't think it's not going to be like JavaScript where it just grows on anything. I wouldn't imagine anyway. Let's go. Let's do that. Here's my compile. And then run it. Okay, so the undefined behavior, it went ahead and just exited. That's what happened there. So, and it says in this book, the C++11 book, that it's undefined. So apparently Microsoft treats it like that and just kills everything. and then without it, it runs fine. So there we go. So undefined behavior when you're out of bounds. Doing that. Now, if we did this, now what is the at? I take it it's going to be a Boolean. So if numbers 8 or how would I do that? How would I even write it? Let me see. Where is at? Copilot, where are you? At, let's see. Give me examples. Plus methods. All right, here we go. So v.at2 and then that. Okay. So numbers, if numbers.at, and then we do 8. So how would I do that? Does it return a Boolean? So it throws if out of range. That's not good. I don't like that. I'd rather it return something, especially since it's a method. I'd rather it return. But we're not asking that. That's why. Yeah, I thought it was actually, I'm asking if it's available. So you'd actually have to do size. Where's the size? So like a size of or count. Just pop back clear, assign. There's size. Size equals v.size 3. Okay, so okay, this is weird. Greater than or equal to 3. What does that even mean? That's ambiguous. v.empty false. Okay, there. So what we want is the size. So you would actually have to do size on this. So we'd say if numbers dot size is greater than 8, then do it. Yeah. So it should not do it. Not greater than 8. Woohoo. Okay, so let's do that. Make that 10. Well, we get a bunch of zeros in there. I like that. That initializes them to 0. That's cool. Yay. Yeah, 55. But see how the 5's on the end? It's always on the end. Push back, because always push it on the back of it. So we put that on 5, and then we put the 99 at 0, or the 5 at 10. 99 at 0, or 9 actually, and then 55 at 8, or 7. Okay, that. What else is there? Empty, blah, blah. Oh, there we go. Remember I was talking about initially declaring it to what you wanted or what you think you're going to use. So apparently you can do this. Avoid many reallocations during growth. So I guess it reserves 1,000, but it doesn't go ahead and commit it. Then you can resize. Okay. This is interesting, but it could be, if you did it a lot, I don't know if it would be slower, real slow. So when you do your shuffle algorithm, you do the Knuth Shuffle, what you want to do is you want to take your random number from the whole thing, and once you grab that, you're going to push that out, and then you're going to shrink your field. So you could actually use this to resize down to 4. Like if you had 5 here, this is growing it, but you would actually shrink it down. So if we had 2, we'd remove that one, and you need to shrink your field down. You'd actually replace it with your Knuth Shuffle. So if we took 2, we would exchange it with 3, and then shrink the field down, so now you only have 1 and 3. That's how that works. Or if you don't have like a resize, you can keep a counter of where you're at, kind of like a stack pointer or instruction pointer on a CPU to show where you're at. So if we had 100 numbers and you're, shuffling 52 cards, your pointer would be at the very end on 52. And so that's your range. And so you'd pick one, say you pick number 10. So you would exchange 10 with 52, and then you move your pointer back down to 51, and that's the end of your array now, because you already picked the 10th one. And by the time your pointer gets down to 2 or 1, then you've already shuffled everything. See, that is the Knuth Shuffle. I think there's more variations, but that's the one I'm familiar with. So I wonder, you know what, I might just go ahead and do that. Let me see. But I wouldn't want to keep calling this 51 times, to do that. I think I would just use the pointer of where it's at. I think we should go ahead and do that. Let's see here. We could do this. Number, let's do this. Let's do, whoa. All right, Microsoft, what are you doing? Somehow. So 52. We don't need this. We do not care about that, because we are doing a Knuth Shuffle. So let's do this. What I loved about JavaScript is you didn't have to resize anything. Man, it's so forgiving. I need a sip of coffee. All right. So let's call this. This is going to be void because we're gonna operate on this global one. So let's do Knuth Shuffle. We're going to use some Python nomenclature. Whoa, what am I doing? See that right there? The snake case. I don't know where they came up with that one. All right, we don't need nothing there. Let's do it. We need a random though. I don't know what I should do. Should I just grab the good random, or should I use just random and seed it? Should probably use the other one. Where's it at? Is it in main? Nope. Main 2. Do we have a main 2? Ooh, we got it right here. Heck yeah. There we go. We'll say, let's see, we're gonna do that. Integer. We'll use snake case again. I guess one of the best parts of Python was that. Get random numbers. There we go. So what are we doing here? Where's my control tab or shift tab? All right, we are doing, now this is what we're going to control here. So let's do this. We're going to take the number there. This is going to be max. Max. We don't want that. We actually want 1. Well, no, because we're going to be returning the index. Well, it's still valid because 0's valid. Okay, we can do that. So max, Knuth Shuffle, we will do. Actually, this should be. You really wouldn't do this. If you were shuffling, you wouldn't keep calling this every time. So let's just do this. Let's put this whole thing in here. Just like that. So we need, what is it? Random? Maybe? I can't remember. Let's see. Random and memory. What was memory used for? I don't think it's a part of that one. I don't remember. I don't think we need it. Alright, let's do random. Okay, standard RAM device RD, blah blah. We're gonna use an MT19937. This is good. We have our max. We don't care about that. Let's do this here. This, we could actually, max equals, let's do, what would it be, 52. Now we don't want to actually get 52. We want it lower than that. So that. Now these will be initialized to 0. You know what? Is there a way to do that? We need to. Hold on. We need to do deck. Alright, for what will this be? Auto. We don't need reference there. Numbers. Okay, this is the place where we don't need auto. Unless there's some kind of way of initializing something there. 4, let's see, I equals 0. Actually, we want 1. Nah, we could do that. Equals 1. I is less than 52. Plus plus. Back. And then see numbers I equals what I. Okay, so that'll do that, and then we'll print them here. For numbers, and then C out I. Whoops. No, it should be I. All right. So at that point, we should have those. This not yet. That we definitely don't need. There, but we do have the number here. So we're not doing this yet. So let's see if we got our numbers. Like that. Okay, so we got all our zeros. We're actually not supposed to have zeros. Did we ever set those? Oh, I never called it, did I? Oops. See init. Nice. Smooth move. All right, let's do that. Okay, we got them all. 0 to 51. Yay. So, all right, now let's shuffle, and then we'll repeat that. Let's see. Shuffle. There. And then, in the spirit of copy and paste, in the spirit of doing things you're not supposed to do, we're going to do that and do it again. So now, inside here, okay, we're going to have this blah, blah, blah to max. This is going to actually change. So from here down, oh man, I grabbed the one. It's hard. I'm actually hoping to get some work today. I think doing some landscaping. Yay. Get some quick cash anyway. Alright, we don't need that. What we do need though is max. After this, we're going to max there, down to that. Standard uniform. Okay, we picked the number here. Blah blah. This here. Let's see. So vector. Whoops. Vector. Actually, it would be this. Pick the number. And then we're gonna. Actually, we need to swap this. So let's make a temp. Int temp equals vector that, and then because we got to swap this out, and then vector 52 or max. Oh crap, that's gonna overflow. Should be max -1. Wait a minute, does that? Is this inclusive? I don't think it's inclusive. I think it's going to go 0 to 51. Good grief. Really? Okay, let me see. Uniform int distribution. Oh man. Yeah, it is inclusive. Okay, so we need to do a -1 on that. That's 1. So I hate that. Since we're actually doing this, max is going to equal 52 minus 1, and that way we don't have to include it here. So our total is 52 cards. Let's just do this. This is better. Let's see, int total cards. Let's just do deck count equals 52. So it's 52 cards, but we're actually using 0 through that. So there. And now we don't have to do all the gymnastics down here. So we have that. It is inclusive. You know, a better one would be this here. Copy that. This is a better comment. So we do that. We pick a number 0 to 51. And then we assign that number in the vector to temp, which doesn't make sense actually. Vector, we don't need this. So temp equals this here. We don't want the vector in that. We just want this number. Temp number, so vector max, the end of it equals that. So we have our number. Oops, we don't want that either. We want this to be vector, this right here. Vector max. No. Hold on. So we're picking the index. So we want vector index to equal the end. So yeah, that's right. So vector index, we need what's at that point. So we need that vector max, because we're going to swap this. I wonder if there's a better way of swapping in C++. Ooh, let me look it up. Because we are progressive. C++ swap values. Ooh, there's a standard one. Okie dokie. Let's do that one. Standard swap. Yay, we don't have to do this. Okay, so we can do std swap. What are we swapping? We are swapping vector dist. What did I do? Dang it, where is that? What is it? Dist engine, that's it. Dist engine. Where's our engine? Okay, got that. So we need to swap vector dist engine with vector max. Now, you could just do that too, instead of doing it down here. Swap that. Whoops. that, do this, do that, and there you go. Now we decrement max and we do it all again. And there you go. That's it. That is a Knuth Shuffle. This, that should happen there, and then we should go through them there. All right. Let's do this. And it probably has something to do with swap. Let me see. Oh, vector undeclared. No. Oh, I wrote vector instead of number. Oops. Where's that at? Right here. All right. Is that the only place? Numbers, numbers. Yay. So we got that. These are numbers. Through 52, 51, 0 to 51. Let me put a breakwater in there. A breakwater. Let's do this. See out. We need this. All right. Oops. And then a new line, and there we go. Let's do it again, because this is what we love to do. And let's run it again, and there we go. We count them right here, our deck of cards, and then we do a Knuth Shuffle. All right, there you go, guys. There's your Knuth Shuffle. If you was always wondering how easy it is, right there. That's it, brothers. All right, guys, that was actually pretty fun. We got to see the Knuth Shuffle. Didn't go over every method, but it's 11:30. I got stuff to do. I'm hoping that guy calls, man. All right. That's it for this one. Like, share, subscribe if you like this stuff. Hey, give a comment. Tell me what you're up to. Anything, really. And you could actually even buy me a cup of coffee on PayPal or whatever, however it works. I don't know. PayPal's cool, I think. I don't know. Hey, have a good day. I'll see you guys later. Bye-bye.